Okay, so hello everybody. I'm Ido with lakeFS. With me is Amit. Hi, Amit.
Hey, Ito, how are you?
Good, excellent. And we are here today to speak about mastering data pipelines version control with Medallion architecture, of course, in the context of lakeFS. So thanks everybody for joining. Just a few housekeeping rules before we get started. Everybody is on mute. If you have any questions, if you're on the Zoom, feel free to write them on the Q&A questions. You are all, we have a nice list of attendants here on Zoom. You're all anonymous. If you post a question, it can be either anonymous or with your data. Just be aware that you should be able to choose either way. If you are listening on LinkedIn, you can also write questions there, comments there on the LinkedIn broadcast, and we will answer those here live. We'll make sure to answer those. As we are getting started today, we're going to talk obviously about Medallion architecture and how to achieve that with lakeFS. It will be super helpful for us if to know in what level should we have the conversation, because there's a nice group of people here. It will be nice to know if everybody has been using lakeFS before, has not been using lakeFS before, is using Medallion architecture or not. Okay. I'll wait 20 more seconds to give some other people an opportunity to answer. Okay, so it seems like the majority of folks here today are newer to lakeFS and are not newer to Medallion architectures. So I will make sure to speak briefly about Medallion architecture and focus on lakeFS and what it works like, although there are people that are new to everything, so we won't skip over anything. So thank you everybody for giving us the context. I think it's going to make it better for everyone here. So what's Medallion architecture in a very high levels? A lot of you seem to be familiar with it. This is engineering best practice way for data pipelines, where you typically have a few logical zones where you work in. These are sometimes called zones 0, 1, 2, sometimes gold, bronze, silver, sometimes raw, and sometimes, like I did here, landing, transformed, and curated, where we start with a landing area where basically everything is just dumped. All the data is dumped from everywhere into that landing area where you have the raw data set that you can always go back to, fall onto, and so on and so forth. If you needed to reprocess data, for example, this is very useful. Then after that, we have that transformation zone that transformed the silver zone, where basically you take the raw data from the landing zone and you transform and do whatever type of data manipulation you do as part of your ETLs in order to create the data sets that will later on be consumed by other people or systems. And once you have those, you put those on the curated, on the gold zone, where everybody can access the data later, where the idea is that the gold zone is the single source of truth, the clear right data set where you can work with before. So that's the high-level approach of the Medallion architecture. We will show an implementation in a few minutes. But before we do that, Amit, this seems a little bit complicated. Why should I even do this?
Yeah, there are advantages with this approach, like, for example, scalability, where you can easily bring the new data source or the new application for integration purpose. You bring that data in easily into landing area. And then it provides the modular approach, like you have a separate isolated modules of your different zones. So you can work independently, you can troubleshoot independently, easy to maintain independently. So modularity helps in that case. And that helps on the testing side also. You can test each zone separately or each area separately and it's very kind of independent modules. And then you will have less conflict. Like if something change in the, let's say in your transformation layer, it's not impacting your curated zone where the customers or your users are accessing the data. So it has less, like, reduces your likelihood of conflict. But there are some cons also, but it brings more complexity because now you have multiple zones, multiple environment, so to maintain, so it's more, makes it more complex. And then also it has difficulty on lineage, data lineage purpose. How do you track the data lineage going from one zone to another? That's also difficult to handle. And also versioning in each zone, like how you handle the data versioning, not just your ETL code versioning, but how do you handle the data versioning so you can, if something goes wrong, you can go back in time and fix the problem.
Right. So I guess if I have a problem in my, because of this scalability and modularity, which is very good, now if I have an issue in my goal, it's pretty difficult to understand what's the raw data set that actually contribute to this goal without versioning everything back in time.
Mm-hmm.
Okay, fantastic. So in this webinar, we're actually going to have a demo where we're going to create an environment that has these three zones, and we're going to ingest data into the landing zone. We're going to transform it in the silver zone, and we're going to have an curated zone for everybody to work with. Before that, it seems like a lot of the folks are also newer to lakeFS. So I want to talk a little bit about what lakeFS is specifically, because it's not a solution that's specific for necessarily medallion architecture, but generally lakeFS is a solution that does data version control at scale on top of data lakes. So the way that it works is that it sits on top of the object store, and it provides Git capabilities on top of a bucket or a collection of bucket or a repository, right? So imagine that you can take a bucket or a group of buckets, and now you can branch them, right? Make changes and commit those changes as you go in the way. Or if you want to promote those changes, you can merge changes from one branch to another, i.e. promoting data changes atomically across the environment. And then the ecosystem of tools that we have in our environment can actually access the data through the lakeFS API, and you get those versioning capabilities, where from a refactoring point of view, we made it very easy. After you spin this up in minutes, the only thing that you need to do is now, when you access your data, you can access a branch or a commit in a repository. For example, you can have your bronze repository where you have the curated data, or sorry, the silver repository where you have the curated data in a branch, right, at the end of the ETL transformation. Or you can have the bronze repository that has an ingestion branch that you can access, right? Those are all branches. And a commit identifier can be the data set in the bronze repository that was fed into the silver ETL side. And all of this will make a little bit more sense as we continue and we show it to you live. And of course, if anybody has any questions at the moment, please feel free to bring those up in the Q&A. The Git actions themselves with lakeFS, the branch, commit, rollback, and so on, you can run those from a lakeCTL command line, from Python code. We're going to show you a Python code that does it soon, or for example, from a web interface. So that's a little bit lakeFS. And in the context of the medallion architecture, what we're going to do right now is we're going to create 3 different zones that are going to be 1 bucket and 2 lakeFS repositories. There is not a mandatory to do this in different repositories. A repository in lakeFS is a logical term, but for the sake of this demo, we'll do it this way. We'll have first the bronze repository, which is going to have 2 branches. It's going to have the main branch, and it's going to have the dirty ingest branch, right? Think of Git for data, right? The way that you work in Git is you have your protected branch that everybody merges into. So we're going to write data into the dirty ingest branch and regularly merge it into the main branch in our bronze repository. Then we're going to have the next repository, the silver repository, that's going to read data from a commit in the bronze repository. And then in a separate branch, run an ETL, and merge that data back into my silver production branch, right? Which is the data after it's already transformed. And at the very end, what we're going to do in this case is we're going to take the data set and we're going to export it to a bucket sitting somewhere else. Now, again, there is no physical need to do this. You can actually have a lakeFS repository, that's my gold repository, or you can just read directly from here. But in this example, we're going to show a way that even if you don't want to interact with lakeFS in any, or you don't want your customers to interact with lakeFS in any way or form, at the very end of this process, we're just going to export the data to a different bucket. I'm going to pause for questions from the audience. If we have any. Okay, no questions at the moment. Okay, so let's talk a little bit about how it works, because this is super important. The way that this works is, the way that lakeFS works is that you have data that sits on your bucket. The data always stays in place in your bucket. And every commit in lakeFS is a collection of pointers to objects that sit on top of that managed bucket. And since the object store is immutable, we do copy and write. So when a new file is created, the next commit will point to that additional file, but files that did not change, you will have multiple commits pointing to the same physical objects. What this design gives us is, for example, if I want to create a new branch to run an ETL, that would be a zero clone copy operation where I can create an isolated environment, run the ETL, and merge it back in. It's both highly performant and it doesn't cost additional storage as well, right? When I want to go back in time, if I want to be able to get the lineage that we spoke about before and see what was the data set that in the specific commit historically that fed all the way back to my curated data, that's done without taking multiple snapshots of the same files over and over again. So everything that we're going to do in lakeFS in terms of branches and commits and merges, these are all going to be metadata-only operations that will not cost additional storage, but still achieve the isolation and the lineage that we're looking for. Again, I'm pausing for questions. This is a remarkably low number of questions for the amount of people that we have in this webinar, but I'm going to assume that it's all clear from here. And with that, I'll hand it over to you, Amit, if you want to describe a little bit the demo that we're going to do.
Mm-hmm. Yeah, I think once we go into demo, we might have more questions. So let me share my screen and I'll walk through demo. But meanwhile, you want to ask another question from the audience regarding what kind of technology stack they have. So that will help in the demo also.
Okay, so we have another question here on top of you, just so we'll know to give the right references as we go through this and we show you. We'll see what technology stacks are you guys using. Just under a third of the people answered so far. So I'll give this, okay, a little bit more time. 2/3 are shy. Here we go. Oh, we go. There we go. Okay. Okay, fantastic. So we have a ton of Databricks and Sparks users here. And the distribution on the public clouds, AWS, Azure, and GCP is literally exactly what you would expect from the market. So, so nothing very surprising. The only surprising thing is that oh, here we go. We have a little bit more, I guess. And we have also a little bit of Airflow users here with us, but it's a smaller percentage.
Okay. So let me share my screen now. 1 second. Okay, thank you. So, okay, so let me hide my Zoom controls. So in case if there are any questions, either let me know. I have hidden my control right now, so I can navigate properly. And as based on the what we heard from technology stack, this demo is focused more around like using the notebook. You can run those notebook in Databricks environment. And I'm using Spark, so that's also very applicable. And this demo I'm going to show in AWS environment, but same you can run in Azure Cloud or GCP also. Okay, so let's do initial demo setup. I'll walk through each step by step how you can run this demo on your own. So the first thing is we have this sample, this demo environment or the sample notebook available in Git repository. So this is the link. You can scan this QR code to go to that. And let's go to that sample repository. So this is lakeFS samples. We have lots of samples here, but today we are going to focus on one notebook focusing around Medallion architecture. To install this sample, you have to clone the repository first. So you need to install Git if you don't have. So just clone this repo. I already cloned this repo, so I have my lakeFS samples repository cloned. So next thing is go to your terminal and go to that particular folder where you cloned it, and then run this Docker compose up. So what this sample repository is, it's going to create a container which is self-contained. Everything is there to run this demo. So the Jupyter Notebook, Spark, and all the required Python clients, everything is available in this container. So once you run this Docker compose up, it will create this sample container here. So again, this in terms of the prerequisite, you need to have Docker to run this container. So now I have my samples repository running. Now let's go to the Jupyter Notebook UI. So just click on this, go to localhost, this port number 8888 to get to the Jupyter UI. And here, as I mentioned earlier, we have multiple samples. Let me increase the size of this so you can easily see. So we have multiple samples here, but today I'm going to just focus on one of this. This is called version control of multiple bucket pipeline. I'll come back to this. So today we are just going to focus on this notebook, but people who are interested in Airflow and other Delta Lake, Databricks notebooks, we have a lot of samples available there. You can test on your own. Okay, so that's the first requisite, to just clone the repository, run the container, and go to the notebook or open the notebook. Next thing is this requires lakeFS server. You can sign up for the lakeFS server in lakeFS Cloud, which is a single-click operation. It's on demand. Or you can, if you want, you can run the lakeFS server locally on your laptop also. Again, instead of running the Docker compose up earlier, if you run this command, Docker compose, and also install the local lakeFS along with that, that's where it will install your sample container as, along with the lakeFS container also. So it will look something like this. I have that also installed here. So you will have the Jupyter Notebook container as well as the lakeFS and anything required to run this, to run all the samples. But today I'm going to also use the lakeFS Cloud. So let me go to the lakeFS Cloud and show you very quickly. You can sign up for this. Just provide your email address and password, and then sign up. Takes a few seconds to spin up the lakeFS Cloud environment. So I already signed up for this. So let me log in to this environment. And once you sign up, you'll receive an email to verify your account. So just click on this link or go to the lakeFS Cloud UI and add your code. If you don't want to click the link for some security reason, you can use this, take this code and copy here in the verification. You'll see there's a, I already verified, otherwise you'll see how to verify, and that's just put the code to verify your cloud account. So once you verify access to the cloud, then meanwhile, it will also provision a lakeFS server. It takes about 2 to 10 seconds to provision a lakeFS server. And once it provisions, you will see it's running here. It's ready. In my case, this lakeFS cloud instance is, lakeFS server instance is ready. Right now, if I log into this, this instance, I have this, by default, you'll have a sample repository, and and we also provide us a S3 bucket to run this this sample notebook. But if you want to connect lakeFS Cloud to your S3 bucket, you can also do that. So for that, you'll go into the lakeFS Cloud and go into the setup environment, and then just walk through the setup process here. If you're on AWS or Azure, you can select that and provide your S3 bucket information in the next step. Let me scroll up here. And then you can just walk through the whole setup process. Okay, so now I have my sample container running on my laptop in a Docker container, and I also have the lakeFS server running. So I'm kind of set up, everything is done to start the demo now. Anything else either I missed or anything else you want to add?
No, there's a couple of ways to start. lakeFS is open source, as I mentioned before, so anybody's welcome to use this. But also lakeFS Cloud is, you can try it if you want to set up quickly. It's 30 days, no commitment needed, and anybody can spin it up for the ease of use or quick of use.
Okay, so let's get started. So now the fun begins, like how to implement the Medallion architecture using lakeFS. So in a lot of scenario, we have seen customers have production QA and dev environment, multiple environments. Within each environment, you might want to set up a bronze, silver, and gold zone. So in this case, but today we are just going to look into, let's say, one dev environment and have these three separate zones, bronze, silver, and gold. Some people call it landing zone. Some people call it raw. And also for silver, some people call it staging or transformation zone. And then finally, you have curated or final, or some people call it gold. So that's what we are going to show in the demo. And don't read too much on the right side. I'll walk you through in the demo regarding the data lineage, how you can track the lineage between the different zones or different environment. Okay. So now there's some small here in the sample notebook. If you run locally, this endpoint will work fine. If you're running the lakeFS server also locally around in this container, then this credentials are fine. But if you're running in the lakeFS cloud, we need to provide the credentials and the endpoint also. So let me just copy this and let's get the lakeFS endpoint. So this is your lakeFS endpoint. You can get from here, or you can copy it from your lakeFS Cloud UI, the admin UI. So let's get this endpoint. Just one caution on the endpoint, don't keep the slash at the end. Remove the slash in case if you have, because we are going to append a lot of stuff in there in the endpoint. So just remove that slash. Next, we need a access key and secret key to connect to lakeFS server. So if you go to lakeFS UI and go to administration page here, you can create your access key. And just copy this access key here. And let's get the secret key. Okay, so let's run this cell. And next thing is we need the storage namespace. Again, if you are running lakeFS locally, lakeFS server, then this will work fine. You don't need to change anything here. But if you are using lakeFS Cloud, you can use the storage bucket provided by us. So if I go back here, as I mentioned earlier, this is the storage we are providing in our lakeFS Cloud environment. Again, you can connect to your S3 bucket also if you want to connect. But just for testing purpose, you can use this storage namespace. So let me just copy this. And also here, make sure that there's no slash at the end. So this is the storage namespace, or if you want, you can also create a subfolder within that. So let's say I want to create another folder called today's date. But don't keep any slash at the end. So what I'm going to do, this will do is like create the repository for this demo underneath this subfolder. Okay, so
yeah, sorry.
Yeah.
It's worth mentioning that lakeFS, every repository has its unique namespace. So if we run this, if you run this a couple of times, then you basically just want to add different subfolders every time.
That's correct. Good. Thank you. Okay, so that was the initial configuration to run this notebook. Next, we are going to create a Python client, lakeFS client, to connect to lakeFS server with all the credentials and endpoint that we provided. And next thing is we are going to verify the credentials, everything is correct or not. So we are able to connect to the lakeFS server, verified, and also get the lakeFS version information just to double check. So if this works, then all your credentials, endpoint, everything is fine. Next thing is I'm going to set up the Spark environment, Spark context. So which will here I'm going to use again lakeFS endpoint and access keys. And in this case, I'm going to use the S3A gateway to connect from Spark to lakeFS. So there are two options to connect from Spark. One is using S3A gateway, which most of the people are familiar with, or you can use lakeFS gateway also, or lakeFS, what do you call that? lakeFS file system. So there are two options, but for today's demo, to make it simple, I'm going to use the S3A gateway. And also if you want to, in this case, we are not going to use Delta, but if you are using Delta also, or Databricks environment, then you can use this, set up this configuration. Okay. So now we have Spark context running. Next thing, we are going to define a function to create the lakeFS repository. So what it does, it just checks if the repository already exists, it won't create, otherwise it will create the repository. So it's just a Python function. Let me increase the size a little bit. Okay, next we are going to set up some of the variables here to use in this notebook, like repository prefix. We are going to create multiple repositories for different zones, like bronze, silver. So I'm going to use some prefix for that. And each repository will have the main branch. You can, if you want to call it production branch or something, you can change this. And then in the bronze zone, we are going to create a dirty ingestion branch, as Ido mentioned earlier. And then in the silver zone, we'll create the ETL branch, and then we'll do some data transformation where I'm going to save in this particular path. And for this testing purpose, I'm going to use just one simple CSV file, like FS test. That CSV file is also included in this container, so you don't have to bring your own data set. So everything is contained in this container, sample container for your demo purpose.
So far we've set up everything that we need in terms of like variables, installation of clients, and so on. And now we can start working with lakeFS and creating the Medallion environment. So excited to see this going.
Yeah. So it takes about 5 to 10 seconds to set up, 5 to 10 minutes to set up everything. And then you can start this demo. So here, as I mentioned earlier, you might have multiple environments, dev, QA, and prod. So you can run the same notebook for different environments. In this case, I'm going to run for dev environment. You can just change this variable to prod and QA. And then I'm going to create the bronze repository. So I'm setting up the repository name for bronze, and also dynamically creating the variable for the storage namespace for the bronze repository, as well as doing the same thing for silver repository. Okay, next thing is the gold environment, where you are going to create your final data set of the gold or curated data set. That in this example, we are going to export from lakeFS repository and dump into an S3 bucket. So that will require an S3 bucket. So for that, you can use your own S3 bucket, or you can skip this step for exporting to the gold if you don't have an S3 bucket of your own. In this case, I'm going to use my own S3 bucket, which is this lakeFS Cloud Dev Gold. So let me just copy this.
And of course, lakeFS is not specific to AWS. If anybody is in Azure or GCS or Minayo or on-premise, we have support for all of those environments. So,
okay. So this is where I'm going to store my final data set. And again, this all your front-end customers or users will be basically connecting to this this bucket. And in this case, I'm using S3, but if you are using Azure, then it can be blob storage, so where we can export it to. And right now, this is empty. There's nothing in there. Okay. So another thing, I'm just going to verify my user account. So I'm connected as myself to lakeFS server. I'm using this lakeFS client, which I created in the beginning. Okay, let's create the repositories now. You can create the repository from the UI if you want to, lakeFS UI. You can create the repository, provide the name and the storage namespace, but we already set up everything here in the notebook. So we're going to create this repo from here, just call that function that we created initially. So I'm going to create two repositories, one for bronze and one for silver. In this case, I'm using the same S3 bucket for both the repository, but you can have in separate buckets also. You can use multiple buckets to create these different repos. So if I go here and refresh my page, so now I have my dev bronze repository, dev silver. So again, if you're using prod environment, you can have prod bronze or prod silver. You can also have a different naming convention if you want. Okay, so here, this is under this storage namespace. You can see it's a different subfolders here, but it can be also in totally different S3 bucket. Okay, so my repository is ready. Now we'll go through the process that Ido was explaining earlier. So what I have my bronze repository with the landing zone where I'm going to create a dirty ingestion branch and ingest the data in that branch. The reason we do it, like in case if something goes wrong, you can roll back the changes easily, or you can, before you merge the changes into production, you can just delete the branch if something is wrong. So you don't impact your main branch. So let's create this branch. Again, you can create the branch from the UI if you want. So if I go into my branch repository and the branches here, you can create the branch from here. Or right now we have set up everything here. So I'm just going to create this from notebook. So create this, the ingestion branch. So if I go and refresh here, so now I have my ingestion branch in my bronze zone. Okay, now I'm going to ingest some data. In this case, as I mentioned earlier, I'm going to use a simple CSV file, which is also included with this demo container. So I'm going to upload that CSV file to lakeFS repository. If you're using Spark, you can read a file, create the data frame, and then load into lakeFS repository. I will show that in the next section here. Okay, so let's upload this CSV file. So here is my CSV file name and the physical address where it got stored. So for data lineage purpose, we have all that information available in the lakeFS repository. So, and next is commit all the changes. So in this case, I have one CSV file, but in your case, you might bring in multiple files, different types of file, Parquet file, Avro file, whatever you have. And then once everything looks good, you can commit your changes. Again, this is still a landing zone. We are not doing any transformation so far. So when you commit the information, you can attach a lot of metadata in lakeFS, which will help, which is used for the lineage purpose. So for example, let's say I want to have a data classification. Like what kind of data is this? Is this a raw, red, yellow, green, or something? So a raw green in this case. What's my source? It's my bronze repository. And this is my target file, dynamically generated. So if I commit, I'll show you that information, how it looks. So here, this is my basically a target file. That's that CSV file, which goes to the lakeFS repository. So if you click on this link, it will straight away take you to that file in lakeFS repository. Again, this is a very basic, simple CSV file with the 5 columns and just one single record to keep it simple. Okay, and once everything looks good about your data files and you are satisfied, you can merge this information into the main branch. So far we brought this data into dirty ingestion branch, just to the quick check, make sure all that looks good, and then merge into my main branch. So if I go back here into my lakeFS repository, So if I go into main branch now, I have that CSV file in my main branch also. Okay, so far looks good. Anything else to add, either? Like I'm just still working on the bronze. Now next I'll go into the silver side.
Yeah, incredible. So what we've done is we created an ingestion branch, wrote into it, merged it back into this, and this allows us the ability to go back in time in the commits of seeing the raw data sets in every time, again, without the need to take multiple copies of the same file. So that's pretty awesome. And the next, we said we're going to somehow be able to point to that commit when we go and we transform the data and the silver branch, right?
Correct. Yeah. So you can basically, in this case, as you either mentioned, like we have all the history or lineage of all the changes that are happening. So we created the repository, added our CSV file, and then we merged that branch into the main. So all that history is there. And also, once you look into this particular commit, like for example, here you have all the source and target information. And if you are not into your notebook, for example, if you come straight to lakeFS and you go to individual commits, from here you can also go into your target. Using this link, you can just go into the target file. In this case, again, this is your CSV file. Okay, so we have our bronze zone, everything ready. Now I want to create my silver zone and run some transformation in my silver zone. So I'm going to read from my bronze repository. So again, I'm going to use the S3 gateway from Spark. So I'm going to create a data frame by reading this from bronze repository from my main branch, and that's particular CSV file. Right now, I'm trying to read from the main branch, but you can read from any commit also. So like, for example, in this case, if I go to this commit, you can just copy any of this commit and then copy that and then use that to read from instead of using from the main branch. Or sometimes people tag the information after commit or in between the commits. So they might have tag, okay, my tag for yesterday or last week. You can use that tag also to read the data set. So let me run this. Again, this is just going to the bronze repository, read from the particular branch, that particular file, and create my data frame in Spark. Again, simple 1 row, 5 columns. And then also get my commit information. In this case, again, I'm going to lakeFS and get the commit log information just to verify everything looks good. So this is my commit details, just to verify my source and targets. This is my target file. This is just to verify my commit information, which you can get from the UI as you saw earlier. Okay, so now in the silver repository, we are going to create an ETL branch where we are going to run the ETL job. Again, we run this in isolation from your main branch. The reason being is, let's say if some ETL job fails, something goes wrong, you don't have to merge that branch into your main branch. You can just delete that ETL branch without impacting your main branch. So this gives you a very good isolated environment to run your ETL job. Some of the ETL jobs might take hours to run, so you don't impact your main branch. And also you have capability to roll back the changes. Let's say you merge something into main, but then you realize something is wrong, you can roll back and go back in the history to any previous commits. So let's create the ETL branch here. So now if I go into my silver repository, and right now everything is empty here, and now I have this silver ETL branch. Right now there's nothing in there. It's just an empty branch right now. And I'm going to run some transformation. In this case, I'm going to do transformation using a Spark. And in this case, I'm going to partition this CSV file, this data set, and I'm just going to partition by first column and write to lakeFS repository. Again, to write to lakeFS repository, I'm using S3 gateway.
Very complicated detail.
Writing to my silver repo, to my ETL branch under this path. So if I go back here in this path here, in this silver repository, I have this data set, which is partitioned by this first column. Okay, so now if things looks good, you can commit your changes. So in this case, I run just one simple ETL job. In your case, you might run lots of transformation. You can use Airflow. We have samples for Airflow also. If you want to look into that, you can run multiple transformation, multiple pipelines. And once everything is satisfied, you can commit your changes in the branch. And you can do commit in betweens also. Let's say you're running lots of transformation, you can commit in between. So you can even have full lineage information. And in this case, I did just one transformation. I'm going to commit that changes. Again, once you commit, you can add your metadata along with this commit. In this case, the classification. This is my transform data set. And it's a green classification. You have source and target dynamically generated also here links. So this is my source. So my source is basically this CSV file coming from my branch in the main, from the main branch. So again, this gives you data lineage. You can easily track all this information. And this is also this information not available just here in the notebook, but also if you go in the commits here, in this case, in the silver repo, you can see all this metadata here and also go to the source and target UI.
So I'm in the silver repo in the UI, right? I see a data set, whatever it was transformed. And if I want to see where it came from, right, I have the code, what I ran. I have the files that were changed or created. And if I want to see where it came from, I can open the source commit UI and see the data set that fed into this.
Correct. So this is the source commit. And also you can look at the data set also, like if I go to source UI, it will show me which CSV file, which data set I used, and what commit I used from the source, from my branch repository. Okay.
Great.
So now let's continue here. So once you finished your ETL job, everything looks good. You can merge that change into your main branch. So this is basically all curated data available in the main branch. So if I go into the silver repo in my main branch, so now I have my silver data set with all the transformation done. So now my silver repo is ready. All the changes, all the transformation which I had to do, everything is done. And now I can take this data set and move into my gold zone. Again, in this case, I'm going to just export this data from lakeFS repository and dump into a S3 bucket. As Ido mentioned earlier, if you want, you can create another repository here for gold, and people can access the data from lakeFS. But in this case, I'm going to just dump this into an S3 bucket, and people can read directly from S3 bucket. If you want to track if somebody is changing data in gold zone also, then I will recommend to create the repository in lakeFS. Then you have full lineage tracking and everything and rollback capability. But if people are not going to change any data set, then in this case, then you can just export and put in the gold repository. Oh, sorry, gold bucket. So I'm going, as I mentioned earlier, I'm going to use this gold bucket here to export to. And for this, we are going to use this rclone functionality where it clones the data between different buckets. And also this rclone keeps the sync between the two environment. So let's say if I export this data today, it will just copy all the data set into that gold bucket. But if I run it again an hour again later or next day or nightly basis, it will just sync all the data, any changes that happen. So it won't take that much time to sync again next time. Okay, so to run this command, first I need the connection to my lakeFS server. So I have my lakeFS access key and secret key and endpoint. But to write to the S3 bucket, I also need the AWS keys here. So I have my keys here. So let me just copy this AWS key.
as we record the webinar that will be published later on.
Yes, I'm going to delete my keys after the demo. Okay, so let me run this. So this will, if you run this, it will give you a command to run to export the data from your Silver bucket. So if you see here, it's from Silver repository, it's pulling that data set and using the arc clone to write to this gold S3 bucket. And in this case, I'm exporting the main branch. You can export any from any commit or any branch or any tag, as I mentioned earlier. So instead of using this main branch, you can say, give my commit ID or my tag information or another branch, and then export from data from that branch. Oops, sorry, I clicked this link by mistake. So, okay, so now I'm going to just copy this command here and run from my terminal. So what this will do is it will pull this container, the arc clone export container, and run this command. So let me go to another.
And of course, this is completely optional. I would say that actually most of our users use everything within lakeFS, but we're showing this as a way to export data out if someone wants to get the data in a regular format where everybody can access it.
Mm-hmm. Right now, I have a very small one data set, just one CSV file, and then in the Silver, we did some transformation. So it was pretty fast, but first time when you run, it will take time, depending on how much data set you have. And if you run periodically, then it will just do the arc clone sync and just do the changes only. So now if I go into this gold environment or gold bucket here and refresh, oops. Did I make some mistakes here? 1 second. Which bucket did I use? One second.
You have a subdirectory there? No, right?
It did copy. Local file.
Yeah, I mean,
something happened. I have to check what happened.
The beautiful of a live demo, but I think the good news is that we got all the way to the last point, and we'll figure out if there's any changes that need to be done. I doubt it because we use this many times. I'm sure it's just something for running this twice in comparison. In the meantime, I'll share my screen. Is that okay?
Yep.
Okay, fantastic. In the meantime, here we go. So we covered a lot of stuff. So just in a quick overview, we talked about the medallion architecture in general, how to create isolation, in every layer, whether that's through ingestion that's done in a separate branch or through an ETL branch that's done separately, so you can easily roll back, so you can easily create lineage, how to export the data, how everything is done with zero copy clone for savings and storage in high performance. There was a lot to take here. Data classification as a part of the commitment and so of the commits and so on and so forth. So this is recorded. Not only this is recorded, I also want to share with you guys that we also have a blog post, version control data pipelines at Medallion Architecture, where we wrote this down step by step, so you can see that also. If you, this recording is probably a little bit better, but different people like to use different types of media to follow. Now, everything that we showed you today is a part of the lakeFS open source solution. lakeFS is open source, and literally everything that we showed today is available on the open source solution. We also have a SaaS offering, lakeFS Cloud, that comes with some enterprise features or some additional features, right, such as role-based access control or single sign-on, or of course, anything that has to do with a managed service, right? Disaster recovery, auto-scaling, auto-updates, SOC 2, managed garbage collection, and so on and so forth, managed services. Or if you do not use the cloud, which is not the case at least from what we got in the responses of these questionnaires, then then you have the ability to use this on-prem as well. I have one more question to ask before I go and I leave you with some additional points.
And also, either before I ask this question, I fixed the problem. Let me show you quickly. Let me share my screen. I made a small typo or a small mistake there. So just quickly, I'll show what I did. I forgot to use S3. So it was copying into my local some storage space. So once I change this to S3 and ran that command again then I have this data set in my S3 bucket.
Okay, fantastic. In the meantime, before I share some more things with you, I will say that we also have, okay, it looks like this was very helpful for those who answered, although I think a small subset of the folks are still have the energy to answer a poll. So I appreciate those of you who answered. Thank you. We will continue on with, we will follow up with links to the recording of this thing. I'm going to wait one more minutes to see if anybody else has any additional questions as we go. Okay. Great. So just for everybody's sake, we have a pretty awesome Slack community that's very responsive. We'll share this over. If anybody wants to join, they're very welcome to. We talked about the ability to bring lakeFS really quickly, and we'll send the link for that. And we'll send the link for this sample repo as a part of the follow-up. So everybody here will have it. I will wait a few more seconds to see if anybody has additional questions, or Amit, if you have any questions that I can help you answer.
No, I think you explained how lakeFS works internally, like zero code copy, which is very important piece of information. So thank you.
Thank you, everybody. We had a few dozen people here on today on different platforms. So really appreciate everybody's time. We'll hang out here for 30 seconds or so and see if there's additional questions, and then we will end the call. So thank you, everybody.